IEEE 802.11 2019 will be the next high-throughput WLAN amendment. Partly because of their own success, next-generation LANs face two main challenges. First, they must address dense scenarios. Second, increase users' throughput needs. Dense LAN scenario is when LAN user density, users per meter square, is very high, which then require deployment of many access points close to each other to achieve high data rate. The examples are stadium, train or apartment building. The challenges in high-dense LAN are related to interference issues, which increase the packet error rate and reduce the number of concurrent transmissions. Additionally, the presence of many stations, STAs, in the same area increases the chances of collision among them. We will explore 4 new features and concepts introduced in the IEEE 802.11 2019 amendment, which are spatial reuse, temporal efficiency, spectrum sharing and multiple antenna technologies. Trade-off can be reached by adapting transmit power level, CCA level, and directional transmission. Reducing the transmit power reduces influence area, benefiting the spatial reuse but resulting in packet error, lower transmission rate and hidden node. Concentrating the energy toward the destination improves the spatial reuse. Packet header overheads can be reduced by using variable header size and minimum required fields. Packet aggregation helps to reduce temporal overheads. We can piggyback the ACK with data to improve the efficiency. However, the current setting of the network allocation vector needs to be changed. Packet error is the major source of overheads, and can be reduced using the incremental redundancy-based automatic repeat request. By allowing full duplex transmission between AP and STAs, the capacity can be doubled. Alternatively, SDR capability can allow LAN to replace collision avoidance with collision detection. Collisions are very wasteful of channel resources in LANs. Enhanced CSMA/CA can be used to minimize collisions, and it is good replacement because of its backwards compatibility. Its main difference with CSMA/CA is the use of a deterministic backoff after successful transmission. There are 2 approaches to improve spectrum efficiency. The first is to dynamically adjust the bandwidth allocation. Only perform allocation on users' demand. Users with higher demand receives higher allocation. This essentially allows any unused spectrum gaps to be filled and maximize capacity. The second approach is to split existing channels into smaller sub-channels. This will result in each user having lower data rate but higher average throughput in the whole network. Combining this approach with the first one, the network is able to serve more users simultaneously. Spatial multiplexing use multiple antennas at both access points and stations to achieve high throughput in wireless LANs. IEEE 802.11 2019 will continue implementing SU-MIMO and downlink MU-MIMO. It may also include or provide support for uplink MU-MIMO, massive MIMO, network MIMO, and distributed antenna solutions. Multi-user MIMO enables multiple simultaneous transmissions to different stations from the access point in the downlink, and from multiple stations to the access point in the uplink. In the downlink, a challenge will be reducing the channel sounding overheads. To support MU-MIMO transmissions in the uplink, it must detail how the uplink CSI from each station is obtained by the access point with a mechanism to signal a group of stations to simultaneously start a transmission. Massive MIMO refers to the case where the access point has many more antennas than stations and uses them to create a nearly identical number of point-to-point links as the number of active stations. In coordinated wireless LAN deployments, network MIMO can be used to minimize the interference among simultaneous transmissions from different access points. We have reviewed some technological solutions that can be included in the next generation LAN. Individually, all those solutions can offer some performance gain. However, assessing performance gain when all those solutions are combined is still an open challenge.
Created using Powtoon.